Hello students, welcome to KLS Gokte PU College of Commerce and Science, Belgavi. This is our sixth lecture on a topic surface chemistry. This is Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. I hope you remember what we have learned in the last class. We discuss about the various types of colloidal solution based on various factors. And today we will discussing the various points. Let us have a look towards the contents of today's class. The first one, the craft temperature and CMC, that is nothing but critical micelle concentration. Secondly, we will discuss about how to prepare the colloidal solution, that is preparation of colloids. Then we'll study the properties of colloids and also some application of colloids. And lastly, we'll try to understand what is coagulating value and flocculation value. These are the contents of today's class. Let us try to understand one by one. The first one is the craft temperature. The craft temperature is a very simple. The temperature at which the micelle formation take place, that temperature is called a craft temperature. The formation of micelle take place only above a particular temperature is called craft temperature. Now micelle is nothing but what? Associative colloids that we have discussed in the last class, right? The micelle is nothing but what? Associative colloid. So the formation of associative colloid take place only at a particular temperature is called craft temperature. Now next one is critical micelle concentration. The concentration above which the micelle formation take place is called critical micelle concentration. So at a certain concentration above which the micelle formation take place is called critical micelle concentration. For example, soaps, synthetic detergent are the example. So particular concentration will be there above which that micelle concentration or associative colloids forms. Such type of concentration is called critical micelle concentration, and these two definitions are very important for the final examination. Now let us know how many methods are there to prepare the colloids. See, we can prepare the lyophilic colloids as well as the lyophobic colloids. And I hope you remember the difference between the lyophilic colloid and the lyophobic colloid. Lyophilic colloids, they have the great affinity towards the dispersion medium. Whereas in case of lyophobic colloid, they don't have great affinity towards the dispersion medium. So therefore, the lyophilic salts can be easily prepared because they have the great affinity towards the dispersion medium. So it can be easily prepared by shaking the lyophilic material with a dispersion medium. Example, preparation of star sol. So we can prepare the star sol very easily by shaking with the dispersion medium. But in case of lyophobic colloids, it's very difficult sometimes because they don't have the great affinity towards the dispersion medium. And therefore, in order to prepare the lyophobic colloids, we have several methods. So there are two methods to prepare the lyophobic colloids. The one is dispersion and the second one is condensation. In dispersion, we will study the various methods, that is mechanical, electrical and peptization, whereas in condensation we'll discuss the chemical methods to prepare the lyophobic colloids. Now let us learn one by one. The first one is a condensation method, or it is also called the aggregation method. In this methods, the method involves the joining of large number of small particles to form particles of a colloidal size. The joining of large number of small particles to form a particles of colloidal size. Some methods are, the first one is oxidation. So in this method we are going to join the smaller particle to form colloidal size particle. Okay, so first one is what? Oxidation. I hope you know oxidation, right? The oxidation is nothing but what? Addition of oxygen or removal of hydrogen is known as a oxidation. That is a simple definition in case of organic chemistry. Fine. So when bromine reacts with the hydrogen sulfide, it forms hydrogen bromide and a colloidal solution. So this is your bromine and hydrogen sulfide. When both react to each other, it form hydrogen bromide, and this is our colloidal soul, that is sulfur. So it forms the colloidal soul, that is a sulfur. So this process is called the oxidation. Why this is oxidation? Let us see here. In this hydrogen sulfide, two hydrogens are present, but in the product hand side, this hydrogen is removed from the sulfur. So the removal of hydrogen is called as a oxidation. The removal of hydrogen is called as a oxidation. You focus on the sulfur. In the reactant side, the two hydrogens are present with the sulfur, but in the product hand side, whether hydrogens are present with the sulfur? No, it is present with the bromine, and therefore we are removing the hydrogen from the sulfur. So that's it. Simple meaning, that is removal of hydrogen is nothing but what? Oxidation. So it is called as a oxidation. Next one is what? Reduction. The next one is what? Reduction. So when AuCl3 reacts with the SnCl2, so it forms the colloidal solution of a gold, that is gold soul, which is purple in color, and it also forms stannous tetrachloride, that is SnCl4. So this is called as a reduction because we are removing the electronegative element, that is chlorine. We are removing the electronegative element chlorine from the gold, and therefore this is called as a reduction step. It is called as a reduction step. Or another way to understand the reduction is what? Yes, you know that loss of electron is oxidation and the gain of electron is reduction. Alright. Now in AuCl3, the oxidation state of gold is 3. But in case of product inside, the oxidation state is 0. So it is gaining the 3 electron and it is reducing its oxidation state from plus 3 to 0. It is nothing but what? Reduction. So gaining of electron is what? Reduction. Next one is a hydrolysis. Hydrolysis is very easy. Addition of water to a particular species is called as a hydrolysis. So FeCl3, that is ferric chloride, when react with the water molecule, it form ferric hydroxide, that is a colloidal solution. And apart from that, we will get the byproduct as a HCl, that is a hydrogen chloride. So this is a hydrolysis. From hydrolysis also we can prepare the colloidal solution. The next one is a double decomposition. So double decomposition is nothing but what? We are going to break the larger molecule into smaller molecule. So here we are having the large molecule, that is arsenic trioxide and hydrogen sulfide. These two will undergo decomposition and it gives arsenic sulfide and water molecules. So these are the double decomposition in order to prepare arsenic sulfide as a colloidal solution. So these are the chemical methods to prepare the colloidal solution via oxidation, reduction, hydrolysis and double decomposition. And these all methods comes under the condensation method in order to prepare lyophobic colloid. So try to understand what is oxidation means. It is nothing but removal of hydrogen is oxidation, whereas reduction, that is addition of hydrogen or gain of electron, is what? Reduction. Hydrolysis is what? Addition of water molecule, and double decomposition, we have to break the larger molecule into smaller molecule. So that's it. So we can prepare the various colloids through the condensation method. Now next one, preparation of colloids. So dispersion method or disintegration method. These methods involves the bigger particles are broken down to colloidal size. Means we have to take a bigger particle solution and we have to break the bigger particle into smaller particle to make a colloidal size particle in order to prepare the colloidal solution. So the method is mechanical disintegration. So mechanical disintegration method involves the suspension is ground well in a colloidal mill consisting of two steel discs which rotate in opposite direction at a very high speed to obtain the particles of colloidal size. So मैकेनिकल डिसइंटीग्रेशन में क्या होता है, वी हैव टू टेक अ बिगर साइज अ पार्टिकल सोल्यूशन. सो बिगर साइज पार्टिकल सोल्यूशन इज व्हाट, आवर सस्पेंशन, वी नो दैट. सो सस्पेंशन इज ग्राउंड वेल इन अ कोलाइडल मेल. सो इसको हम क्या करेंगे, ग्राउंड वेल करेंगे, क्रश करेंगे स्मॉलर पार्टिकल में, बिकॉज सस्पेंशन में क्या होता है, बिगर पार्टिकल्स रहते हैं. सो इसको हम कोलाइडल मील में डाल के ग्राउंड करेंगे इन ऑर्डर टू गेट वॉट, कोलाइडल साइज ऑफ पार्टिकल. एंड दिस कोलाइडल मील कंसिस्टिंग ऑफ टू स्टील डिस्क. सो यहाँ पे स्कीमेटिक डायग्राम में आपको दिखाई देगा, दीज आर द टू स्टील डिस्क which rotate in opposite direction to crush the suspension particles. So we have the driving belt which rotate the steel disc, and these steel disc will crush the suspension particle into colloidal size particle to get the colloidal solution. So let us try to understand this with a beautiful animation. So this is your colloidal mill. So this is the input funnel where we have to suspend the suspension. यहाँ पे suspension डालना है. So this is a control valve, and we should now this is a motor which rotate the two steel disc in opposite direction, and this is adjusting knob. Now we are adding the input funnel. So this is our suspension which consisting of bigger particles. And once we start the motor, the steel disc will start to rotate in opposite direction and we'll get the colloidal solution. Now this is our colloidal solution of colloidal size particles. So this is how practically we prepare the lyophobic colloid by using the colloidal mill. Now the second method is electrical disintegration or Briggs arc method. This is very important method for the final examination. Briggs arc method. See, in this method, electric arc is stuck between the electrodes of the metals. In this method, the electric arc is stuck between the two electrodes of the metal whose colloidal solution has to prepare. So आपको इलेक्ट्रोड यूज़ करना है जिसका आपको कोलाइडल सॉल्यूशन प्रिपेयर करना है. So you can use the gold in order to prepare gold colloidal solution, or you can use the silver to prepare the silver colloidal solution, or you can take platinum to prepare the platinum colloidal solution. So these are the electrodes whose colloidal solution we have to prepare, and these two electrodes are stuck between the electric arc, and these are immersed in a dispersion medium, that is water. The intense heat is produced, and these two electrodes are connected to the battery to produce the intense heat. When the intense heat is produced, the electrodes start to vaporize the metal, which then condense to form the particles of colloidal solution. So यहाँ पे क्या होता है, so जो भी दो इलेक्ट्रोड है गोल्ड के जो इलेक्ट्रोड है, once they are heated through the electric arc, the gold will try to vaporize, and once they start to vaporize, the ice which is present here will try to condense that vaporizer gold into the dispersion medium, and it form the colloidal solution. Are you getting? समझ में आ रहा है? Okay, so let us try to understand this also through the animation.
Electrodispersion method, Briggs arc method. This method is widely used in preparation of colloidal solution of metals like gold, silver, platinum, etc. The method uses two rods of metal which we want to disperse as electrodes. These rods are immersed under the dispersion medium, in this case, water along with some stabilizing agent like potassium hydroxide. The whole setup is placed inside an ice bath or cold bath. The ice mixed with a little salt to make sure the ice doesn't melt so fast. The ice bath ensures the water remains cold. When the electrodes are charged using electricity, an arc is formed at the end. Due to the arc, a huge amount of heat is generated, causing the metal to vaporize. Since the water is still cold, the metal immediately condenses back to solid and disperses to form the colloidal solution. Ele-
I hope you understood through the animation. So it is very easy. Just we have to heat the electrodes. When the metal start to vaporize, the ice which is present there, it will condense the vaporized metal into the dispersion medium and it form the colloidal size particles. So this is our Brady's arc method to prepare the colloidal particle. Now third one, that is a peptization, and this is very simple. This method is used to convert fresh precipitate into colloidal state by shaking with the dispersion medium in the presence of small amount of electrolyte. So we require a small amount of electrolyte to prepare the colloidal solution. So in this method we have to convert the freshly precipitate into colloidal state by shaking with the dispersion medium in the presence of small amount of electrolyte. The electrolyte used for this purpose is called peptizing agent. So we are using the electrolyte, and that is electrolyte is called as a peptizing agent for the formation of colloidal solution. So here we are having the freshly prepared precipitate, that is ferric hydroxide. When it is treated with the dispersion medium with the peptizing agent ferric chloride, it forms the colloidal particles of ferric hydroxide, and this process is called the peptization. This process is called peptization. So let us try to understand this through also animation.
Preparation of colloids by peptization. Peptization is the process of converting a precipitate into colloidal form by shaking it with dispersion medium in the presence of small amount of electrolyte. The electrolyte used for this purpose is called peptization. Peptization. The precipitate adsorbs one of the ions of the electrolyte on its surface. The adsorbed ion is generally common with those of the precipitate. This causes the development of positive or negative charge on precipitates, which ultimately break up into smaller particles having the dimensions of colloids.
So here we can prepare the positively charged colloidal solution or also another negatively charged colloidal solution. It depends upon the precipitate. So generally we require what? The peptizing agent to prepare or to convert the freshly precipitate into colloidal solution. So this is the peptization method. Fine. So the next points, that is about the preparation properties of colloids and the application of colloids, will study in our next class. So students, try to understand the concept, read the books, okay, and try to solve the previous year question paper also. If you find any difficulty in understanding the concept, then you can contact me. Fine. So thank you.